All right, hello everyone, and welcome to the 16th ROS2 Hardware Acceleration Working Group. As always, let me paste in the minutes, in the chat, the minutes, which you all should have access to right now. And with this, let's get started. I see you could join, Raisa. Thank you. All right, so I think it's the screen. Yep. All right, so as always, participation is being kept in the LinkedIn event, so go and check it out. Share if you would like your peaks or your network to also be aware of what we are doing in here. Couple of updates regarding all business. First, standardization effort updates. In the last discussion, in the last meeting of the ROS2 Hardware Acceleration Working Group, we discussed some of the progress that has happened in the OverRep 2014 and some of the contributions we got, including from Raisa and others. Thank you, all those of you that have reviewed Rep 2014. As you know, this document aims to establish benchmarking performance in ROS2 baseline, a series of guidelines on how benchmarking performance should be done with ROS2 and overall in the robotics ecosystem that leverages ROS. So far, and in my opinion, the document has been rather polished based on the feedback provided. And I believe it's fair to say that we've been waiting for a while, and after no further input, I think this is ready to be shipped and hopefully merged finally. It's been, let me check real quick. Yeah, it's been quite a few months since we started this effort already. We left it open for many to comment. I believe that we've addressed most of the comments in the code that I can see. I know there are still some suggestions that were pending left in the discussion, but I think that given the fact that we all have limited bandwidth, those people can get back and implement those suggestions if that's desired either right now or once this gets merged. Reps are very open for improvement always. So unless anyone disagrees, I would say that after the modifications last time, I would vote for pushing this into at least the review of others in the community, and if appropriate, have it accepted. Does anyone has any final comments or modifications he or she would like to further introduce into the document? None? All right, so then I'll take the action of essentially pushing it forward for acceptance. Again, we don't have guarantees, and it's community maintained. At least reps are community maintained. Not sure who is the status of this, given the movement that has happened with intrinsic and so on and so forth. But we'll figure it out, and we'll ping whoever is in charge. Okay, so that's concerning the standardization efforts as part of the working group. Some updates on performance benchmarking, particularly on RobotPerf. So thanks everyone who has been meeting essentially every single week, except the ones wherein we hold the official working group meeting. So we're meeting weekly, once again, for those of you new to this, this time every single week. Tuesdays, in essentially, we are advancing quite a bit thanks to that, especially thanks to the folks in Harvard and thanks to all others who are joining and contributing, commenting, and supporting the effort. I've got some exciting updates. First, as promised, we've got and we achieved fully enabled CI/CD pipeline that does report on the results of RobotPerf benchmarks repository. Let me get a link to this for those of you new to the topic itself. So here's the repo. Let me paste that link also here, just for completeness. So yeah, so far, and again, for clarity, this repository is a meta package, a package of ROS2 packages that contains a series of performance benchmarking tests. Each one is self-independent and should provide all of the resources required to either leverage simulation or ROS packs, whatever it is using, to create compute baselines across computational architectures. So for now, we've been focusing on generating these baselines. We have a couple of benchmarks right now, A1 and A2, but we have an exciting one coming up in a pull request that we'll review in just a bit, contributed by Jason and some other folks. And yeah, this in principle, we've been working on our side to try to generate an infrastructure that automatically grabs every single one of these benchmarks and runs it through a series of different compute baselines. We're mostly focusing on workstation and edge devices for now, but this could also be pushed into data center and cloud instances potentially. And I'm happy to report that we integrated this within the Robot Core framework, aligned with the RobotPerf benchmarks implementations. Results are cached into a local fork right now. So the results, the benchmarks for each one of the corresponding benchmark are currently not being pushed from GitLab into GitHub for various reasons, but this is something we may look into immediately. Right now, here's an example of a pipeline right now running in AMD 64, and here is an example of the artifacts produced as part of that. So this is what the corresponding benchmark produces. There's an analysis folder. As usual, it generates a series of plots that depict the corresponding results of the benchmark, in this case, across the various layers of the ROS2 stack. And if this device has hardware acceleration capabilities, you will see at the bottom in here typically one additional layer that depicts FPGA or GPU and how that maps into the corresponding areas wherein the computation is running. It also generates a series of summary plots considering either one single instance of the rollouts used to produce the benchmark or averages them. And besides that, two couple of exciting new things. There's one aspect that we noticed is that when encountering issues, it was kind of like troublesome, or at least very time-consuming to try to isolate the issue and troubleshoot it. So one thing we did, which we have contributed back, is that within the trace file. So over here, you have all of the trace information that essentially follows the CTF format, and in particular, in this case, uses ROS2 tracing as well as LTTNG. And another thing that happens is that while the benchmark is running, we are launching a script that I'll show you just right now that we have contributed that produces in a headless manner the computational graph. So this is pretty cool because you don't only get the results of the benchmark analyzed and the trace files that were used to produce such results, but also you get actually a dump of the computational graph. And in this case, as you can see, the corresponding thing that's being benchmarked, as we agreed in the past and in past meetings, it's been essentially contained within this namespace benchmark, as we hope all of the benchmarks will. Besides this, we also have a benchmark fork. So this is the official RobotPerf. This one. This is just a fork of this, a clone of it that happens while it's benchmarking. And then this particular clone includes the changes that correspond with the benchmark that was just launched. So in this case, I think it was A1, the one that got launched. So if we go to A1 and we check out the YAML information, well, whatever. It appears that GitLab doesn't show me YAML. But if we were to see this directly, we will see that it has been appended with additional information besides what was visible. And the last bit that's left in this CI pipeline is essentially pushing this directly into GitHub as a pull request. But we'll discuss this later. We haven't implemented this also because we wanted to see what was people's preferences. And frankly speaking, also because results often the case require manual review, at least, depending on the platform and some aspects. It's been validated both in a workstation environment as well as in an edge device with the KR260 from AMD. And as I was pointing out, we have contributed the script that generates the computational graph in a headless manner. It's It's nothing specifically complex, but this is not available right now in the ROS2 CLI tooling. So it might actually be worth considering to contribute this to, I don't know, ROS2 something if I have time for it. And the example pipeline that we just went through it. So yeah, those couple of things are pretty exciting, and we'll touch on next steps afterwards. Jason, I think you have some exciting stuff to share regarding A3. Would you like to take over?
Yeah, of course. Thanks, Victor. So on our side of things, we have been working on a new benchmark, the A3 stereo image process benchmark. And specifically within the ROS image pipeline repo, there's a stereo image process package, which takes in, like a left and a right image, and it produces a disparity map using that information. So currently, I can go ahead and share my screen and talk through a few things. Let me open this right here. All right. Cool. Yeah, so we've currently created a pull request with the benchmark. So if you are interested in how we built it, or if you're interested in, commenting some ways we can improve the benchmark, please feel free. The pull request is in the RobotPerf repo. But I'll quickly talk about what exactly this benchmark does. So right here is the graph of our benchmark. Basically, what we do is we first create a simulation so we can record a ROS bag. And the ROS bag basically has two topics, which publish to a left camera and a right camera image, which is these things right here. And then what our benchmark does is it adds trace points to the left and right images, which is what this image component does. And then what we're benchmarking here is the disparity node within the stereo image process package, which is found in the ROS image pipeline. And basically, we also add a trace point at the end. Once the disparity map has been produced, we then want to measure the latency of how long it takes that disparity map to be created given the image input. So yeah, this is a quick description of what our benchmark does. You can simulate it yourself. I have information about how you can reproduce the simulation. This is an example of what a simulation is. I have a very simple robot here with a left and right camera, and it'll if you record a ROS bag, you'll see something of this sort where you have your left and right image feeds with the robot driving around the simulation. And finally, when you're running the benchmark, you can also see how there's a disparity map being produced, so you know that the benchmark is working. We are currently working on analyzing the data that's being produced from the trace points that we've added. That's our next steps. But yeah, feel free to take a look, run it yourself, and comment in this pull request if you'd like.
Yeah. So anyhow, big thumbs up from at least our group and from my side to Jason and everyone else, Matt and everyone over there. I think this is fantastic and a great extension of already the image pipeline benchmarking that A1 and A2 represent. So yeah, very much looking forward to get this inside. I just took a quick look at the pull request, and I think Joe did a pretty thorough review. I don't know, Joe, if you'd like to. Is Joe with us today? Let me see.
Yeah.
Oh, hey there. So to just share your impression?
No, I thought it was really good. I think my big comment is there seems to be a lot of useful code that could be reused in other benchmarks. So not having it just confined to that single benchmark would be very helpful, I think.
Yeah, that totally makes sense. I did see your comment about, let's say, like the simulation code. So we can think about how we want to structure that so that other benchmarks can use it. Yeah, and Victor, I took your advice about just using the image, that one image component, so we don't reproduce our, we don't have to rewrite code. So that was helpful. Thank you.
Yeah, thanks a lot for doing that, by the way. And for everyone's information, the discussion last week was actually towards the fact that even though it was looking fantastic already, we were somehow regenerating some topics. And ideally, we would like for each different data type to keep just one implementation for one node that does the instrumentation, collecting and producing the corresponding information. Because at the end of the day, as we'll see down the road, as we have more and more benchmarks, there's complexity in producing the corresponding benchmark, and then there's lots of complexity in analyzing the data that comes out. And especially this becomes very exciting or complex when you start complicating the computational graph across various edge or workstation subsystems. Like, things start getting really complicated because LTTNG is very flexible, but at the same time also is, let's say, not the simplest system to deal with. And again, capabilities come with complexity. That's totally okay. We're building upon giant shoulders, but certainly something to keep in mind is let's try to reutilize as much as possible, because also many of those analyzed files that we will be producing can certainly be refactored. So Joe, thank you for pushing in that direction, and definitely +1 for that. Maybe one minor thing, Joe, is I think you mentioned something concerning Markdown being more friendly to developers when it comes to each benchmark. Totally agree, and I just wanted to make the comment that the idea, and that's what we presented a couple iterations. I don't know if it was last month or last month, but we presented a series of tools that automatically grab the benchmark.yaml file of each one of these ROS repositories and produces the corresponding readme.md file. And so the rationale behind that is that maintaining a database in Markdown is reasonably complicated, whereas YAML is known to work pretty fine for that. So since, go for it.
So I would say then that, you know, this is absolutely great context to capture in response to that comment on the pull request, because somebody will see that later. Because I think the question I asked after saying, you know, Markdown renders pretty is there a corresponding beautifier or a tool that converts YAML to Markdown? And so for somebody who maybe doesn't attend these meetings as frequently as you all do, myself included, that would be helpful context to see.
Yep, +1. Raisa, I think you wanted to say something.
Yeah, I was just like quickly checking Jason's contribution, and I just meant to ask, did you include the bag file that you use for the simulation so that we can get like the same results that you get?
Yeah, that's a really great question. So the ROS bags will go in like the ROS bags repo that we have in the robot perf organization on GitHub. I have not pushed the specific ROS bag that I used in this simulation because it was very huge. I had recorded, I guess, a minute of my robot driving around in my simulation, and that was very big. So I never got around to recording a smaller ROS bag and pushing that. But all the steps to reproduce the simulation and all the steps and all the commands you need to like record the ROS bag in the exact same way I did is all in the repo. So you could do that until I figure out a way to push the specific ROS bag that I use.
Yeah, so on that, Sorry, guys, just someone entering. So on that, Jason, I don't know if I wrote you this or we discussed it last week, but so ROS2 back record by default records on all of the topics, which if you're simulating means lots of information, man. So you may want to filter in specific topics that you are interested in. In this case, just the two image raw topics that correspond with the two cameras for doing stereo. That's one advice. The second one is just don't take 1 minute because it's just gonna blow. And GitHub has, I think, a limit of 50 megabytes for individual files. I think it's up to 100 megabytes in some cases, but need to double check that. But yeah, I would definitely say so. So if we go into let me actually share again my screen. So if we go into such repo that Jason was mentioning before, which is the ROS-Bags repo, and we take a look at one of the recordings that I did, for example. So this is 61 megabytes already, and again, it's just a monocular camera, but yeah, I was just trying to be as complete as possible. This other one seems to be a bit bigger, below 100 megabytes. So I think that's what you're gonna have to be playing with. If we encounter a strong limitation why we really need to cache bigger files, then we can look into GitLFS for large systems, large file system storage. But I think right now we can just cut it shorter. To be honest, just to generate a reference baseline, I think it should be okay. So yeah, just give it a try. If you don't manage to wrap your head around, then either next week or in one of the upcoming weeks, we can just do a hands-on session and do it together. I'm pretty sure it shouldn't take long.
Yeah, that sounds great. I have it on my to-do list, so hopefully I'll have it in very soon. Yeah, I was just concerned if later on we want to have some like more topics, like maybe the ROS bag size is going to become too big for GitHub, even if we're recording only a very short ROS bag.
That makes sense.
Yeah.
But for now, I'll just definitely take your advice.
And it just may happen. So in which case we'll need to just find a way around. But I think right now we can just properly engineer it until like we have such limitation, and then just figure it out. There's various things we can implement. I just for consistency, I'd like things to remain in GitHub if possible. It's just not a matter of using Git LFS. Like we can pay for it and we can fund it ourselves from Acceleration Robotics. It's just that using Git LFS is like also a bit uncomfortable for the user because it's not just Git clone and that's it. You need to actually do more things, and often the case, people skip that step or those additional steps, and then support becomes complicated. Yeah, because I just Git cloned it, but then I didn't get the big fat files. Why is that? And so I've just have really bad experiences with that. So just trying to avoid it if possible. But yeah, we'll see how we can navigate around it. I'm sure it's going to be fine. So I just wanted to real quick before we wrap. I just wanted to query the group, at least those of you today in here, concerning one question about how should we grab the results of benchmarks that run in the background in continuous integration infrastructure that we are contributing, and how can those results be integrated within the benchmark.yaml files. And the question itself, I'm going to try to launch actually real quick. Let me see if I can see it in here. There should be a polling. I can see it. Oh, here it is. So question is how to integrate benchmarking results. And option number one, I guess, is via pull requests. Should automatically the CI create a pull request that contributes to the corresponding benchmark.yaml file? That's one option. Another option is in a different, I guess, in a different branch. Well, that's kind of like integrated within the PR itself. Yeah, so what other options actually do we have? That's one of the things that I wanted to open up. So that's what we had in mind, just opening a pull request automatically. Do we have any others, or do we want any others? I mean, the beauty behind pull requests is that before we accept a result into the official robot perf benchmark, we will have the chance to peer review it and ask additional questions within the pull request. And this will happen for both automated results that will come from the CI infrastructure, as well as from individual contributors that may have just grabbed our infrastructure and just run it locally, which is totally okay as well. Okay, so I'm not even going to poll the group. I'm just going to write in here group PRs automatically.
Quick question regarding these PRs. So when you do merging, then you need to take care about the priority, which one goes first, and etc. Like you do this manually anyway.
You mean if we have various contributions to the same benchmark.yaml file and thereby conflicts may arise?
Yes, exactly.
Yeah, so I think that's a very manageable problem, because rebasing code in that circumstance is like a no-brainer. It's so from a source code perspective, contributions to individual benchmarks are going to look like the following. So we'll have this file. Actually, let me grab the other one. It has more entries as placeholders. So we'll have something like this, right? And a new contribution will be something like this that I'm highlighting in here. So it's just moving it around, I guess. If we have conflicts, we'll resolve it one by one. It is. Yeah, I think within the pull request we can do it.
Okay.
Yeah, no problem, Jason. Yeah, actually, we reached the top of the half an hour this time we allocated. So I'm gonna also have to, I think, jump into another meeting. Yeah. So any additional questions, comments, suggestions? None? All right, so if not, let's close it for today. Elias, I think you, the guys, and some of us are going to continue hacking on the CI infrastructure, I think, right away, as an FYI. And for the rest of you, thank you for contributing. Thank you for showing up. And if you have any further questions or comments, please reach out. And yeah, very happy to see the participation keeping up. And yeah, looking forward to see more benchmarks appearing in RobotPerf and overall in the hardware acceleration working group. Thank you, everyone. Have a good one.